Okay, so 5.4 deals with the triangle midsegment theorem. The definition of a midsegment is a segment that joins the midpoints of two sides of the triangle. Every triangle has three midsegments which form the midsegment triangle. So if we look at this example, M is the midpoint of AB because it has two tick marks here and two tick marks here, so we know that those two segments are equal, so therefore M is the midpoint. P is the midpoint of BC and N is the midpoint of AC. So we just connect the midpoints with segments and it forms a triangle in the middle of the triangle. And it's called the midsegment triangle. So each triangle has three midsegments. The triangle midsegment theorem states that the segment connecting the midpoints of two sides of a triangle is parallel to a side of the triangle and its length is half the length of that side. So in this triangle, what is our midsegment? DE. So DE is not only parallel to AC, but it is also half the length of AC. So DE is equal to 1/2 times AC. And it has these little arrows here to show that it's parallel. So example 1, we're going to find the measure of CBD. So we're looking for this angle here, CBD. So in order to find this angle, we have to use the fact that our midsegment is parallel to this side of the triangle. So FD is parallel to AC. And it's being cut by the transversal BD. So AC is parallel to FD. I'll put the little arrows on it to show that they're parallel. And our transversal is BD. So what type of angles are CBD and FDB? So what type of angles are these two angles? Alternate interior. And what do we know about alternate interior angles? They're congruent. So if FDB is 26, what's CBD? 26 degrees. CBD is equal to 26 degrees. So we found that because we know that the two lines are parallel and they're cut by a transversal, and we used alternate interior angles. Let's take a look at example 2. So first it's asking us to find PM. PM is this mid-segment right here. What other segment in this triangle can we use to help us find the length of PM?
ln, and you just go L to K and cut that in half.
LK. Because PM is half of LK. So PM is equal to 1/2 LK. What's the measure of LK?
Wait, is that the answer?
Not yet. So PM is equal to 1/2 times 97. What's 1/2 times 97?
Oh, quick math.
It's the third time doing this today, so. So PM is equal to 1/2 of 97, which is 48.5. Now it's asking us to find the measure of angle MLK. So we're looking for this angle here. So here we know that PM is parallel to LK, and we can say that JL is our transversal. So the only other angle we have in this picture is this angle JMP, which is 102.
Oh, the corresponding angle.
They're corresponding angles. Perfect. And what do we know about corresponding angles? They're also congruent. So what's the measure of angle MLK? Well, 102 degrees. Okay, let's take a look at example 3. Find the value of n. So we have a midsegment here and a side of the triangle here. What do we know about the relationship between these two? What is 1/2? So our midsegment here is half of the other 3n plus 12. So how do we set that up in an equation?
N plus 14 equals 1/2 3n plus 12.
Perfect. N plus 14 is equal to 1/2 times 3n plus 12. What do we need to do first to solve for n? Distribute the 1/2. So we have n plus 14 is equal to 3/2 n plus 6. Now we can subtract n from both sides and subtract 6 from both sides. So we get 8 is equal to 1/2 n. And what do we get for n?
4.
We have to multiply both these sides by 2 to get rid of the 1/2. So n is equal to 16. Perfect. We can plug n back into these two just to test and see if we did this problem right. So what's 16 times 3 plus 12? Awesome, 60. What's 16 plus 14? 30. So our midsegment's half of the side of the triangle, so we did it right. Good job, guys. Okay, last example.
Wouldn't n be 4 because like it was like half and like you divide by both sides
So
and then you get 4.
we have 8 is equal to 1/2 n. In order to get rid of that 1/2, we have to multiply both the sides of this equation by 2. So we can get rid of that, and then 18 times 2 is 16. All right, example 4. Triangle XYZ is the midsegment of triangle WUV. What is the perimeter of triangle XYZ? How do we find the perimeter? Just in any triangle. We add up all the sides. So we need to know what XY is and what XZ is. And it already gives us YZ, which is 3. So how can we find XY? This segment right here. It's half of the side that it's parallel to. So what's XY parallel to? UW. Right, it's parallel to this segment. So what's the length of UW? 9. So what's half of 9? 4.5. Perfect. So now we need to find XZ, which is this segment here. So we know that XZ is going to be half of VW. If just this part here, VY, is 4, how can we find the length of YW, the other half of this segment? It's congruent because it has, this one has 2 arc marks and this one has 2 arc marks. So we know that these 2 segments are congruent. So this is going to be 4 also. So what's the whole length of VW? 8. So if VW is 8, then what's XZ? 4. Do we have all the sides of the triangle now? Yeah, so what do? Add them. So 4.5 plus 4 plus 3 is 11.5. That's it.